Ladies and gentlemen, welcome to the Ride to Ride Mechanic channel. How the heck are you doing today? Alright, thanks for coming back and watching another video. I do appreciate it. On today's video, it's almost April 15th, and for those of us here in the US, that means we have to have taxes due. We got to pay our taxes. That's just one of those things, you know. But do amusement parks have to pay taxes? Do they have special tax withholdings? What's that all about? I don't know. Let's talk about load testing rides.
Now get ready. Here we go.
All right, this is your first time here. Make sure you like and subscribe. Do all that stuff downstairs, like comment, share. That helps me out, helps fight the algorithm a little bit so we can actually get out there and grow the channel even further than what it is now. I can't believe how much it's grown in just a short amount of time. It's honestly amazing, and I love the channel. I love the community that we've built up here. It's such a great thing. People can reach out and ask questions, and other people can answer questions if they know the answer, because plenty of times I don't know the answer, but someone else can step in. It's really amazing. All right, so today's subject is going to be on load testing rides. Now, why do we load test rides? Well, there's lots of reasons why we load test rides. The three main bullet points of load testing rides are basically the three high spots of them, is to break in the bearings, help break in parts of the suspension of the roller coaster, and to break in things like hitches and pivots and things like that that don't normally see a lot of exercise. And when they get put together, they typically get put together really tight, and they need to kind of loosen up out there on the track. When we load test something, we typically take weight and put it into the vehicle and then send the vehicle around the track. Now, how much weight do we put in there? Well, it depends really, but there's ASTM standards out there. If I'm looking at my notes here, F2137 and F2291, also the ASTM F24, governs basically how rides are built, how they're constructed, and everything else. And the reason for doing the load testing is actually dynamic loading of the system for testing. Now, dynamic loading is necessary to put stress on all the restraint components and chassis components and everything else to prove them that they are in fact reliable and safe. Now, one of the things is that we don't just like figure, oh, well, you know, we put weight in it and sent it around the track so the ride's perfectly safe. No, this is just on top of all the engineering and everything else that's already done to these rides. We put weight in them at the very end, mainly so the ride will make it back. That's realistically what it's for, but it does fulfill an ASTM F24 requirement that they are load tested prior to operation. Now, that requirement, if I recall properly, was 175 pounds per seat. I want to say it was 175 pounds per seat. Now, there's multiple ways to do this. The one that you see most these days are water dummies or water bag dummies. Two are very similar to each other. Basically, water dummies are a hard plastic shell in the shape of a person that once they're loaded into the seat, operators, maintenance, whoever it is, can come by and simply fill them with water. And bag dummies are essentially the same shape, but they're flexible, they're pliable, they fit into different restraints much better. Now, when you put the wrong water dummy in the wrong vehicle, wrong type of vehicle, the two might not hold that well. That's where we got pictures of like water dummies coming out. I believe I don't remember what ride it was, but I could picture it. The water dummies were coming out of the vehicle as it was going around, not falling out, but you could just see them sloshing all over the place. That's because they should have used the hard shell dummies instead of the soft ones. Water dummies are really expensive, and they do nothing but crack typically, not actually from being tested on the ride, but actually from being stored, moved, installed, taken out, that sort of stuff. It's really easy to drop one of the hard shell ones and crack it. And then when you, it was always a thing with our hard shell dummies, we loaded them up with water, and then as the train dispatched, you can see all the water coming out. Now, a lot of that was just water that was left over that we spilled from the filling process. Some of that was actually coming out of cracks in the dummies as it was going around. So it's typically when you load test using water, a lot of times that train is wet as it passes by because there's some water coming out. It's also one of the nice things, kind of, is that depending on the ride, all you have to do is uncap them or take the cap off the top. It's typically where the head would be. Just take the cap off of it, and continue to send the ride around, and eventually the water will come out of it. If the ride is really G-force positive, then that water is going to have a really hard time coming out of there. Now, typically on these things, either if it's a partial torso where it's like the upper half of the body plus like the knees down below, there's typically a plug or a cap down there somewhere where you can undo that and then let the water out of there. Water bags have the same things. So you can let the water out another way, because on a lot of rides you can take the cap off and send it around and they'll drain probably about halfway just from sloshing left to right, and then they just kind of stop and they stay there. That was the rides I had experience with. They never really had a lot of negative G-force to actually push all the water out the small opening on the top. Another really common one to use, which is the poor man's water dummies, is sandbags. There's nothing wrong with using sandbags. For the majority of my time at work, I always used sandbags because we did not have plastic water dummies because they were too expensive at the time. So we always used sandbags. We would just go get a bunch of sand, load them up in the bags. These are the same things that you would use to create a water barrier on something. And we would simply just put those bags in the seat. Most of the time we stacked them 4 to 5 bags per seat. Now the hard part about sandbags is that they aren't meant to be load tested with. By that I mean it's just a bag. There's nothing else on it. So the problem with sandbags is that once you get them in the seat, you have to close the restraint down, which can be very troublesome. You're constantly moving bags and stuff like that. And then the next thing you have to do is use an industrial shrink wrap, which is, imagine like a plastic shrink wrap you use to like wrap a sandwich up or something like that. It's that, but the roll's about 3 feet tall. And you keep going around the seat, around the restraint and everything else, because you have to keep those bags in the seat. Now, that's in conjunction with ropes, straps, ratchets, everything you could think of to keep the sandbags in there, because sandbags shift during load testing, and unlike a water dummy, there's nothing to keep them in. They're much smaller than the restraint is. You could fit 4 or 5 of them in a seat. What I always did was we sat one down where the left leg was, one down where the right leg was, and then 2 across where the butt would be, and then we typically piled 2 more on top of that. So we had a total of 6 bags in each seat. And then we had to try to secure those as best as possible, because you don't want them coming out. Because if they come out, they can do some serious damage, like really bad, very dangerous. This is one of the primary reasons why we don't load test with the park open. People that have plastic water dummies have made the investment, they put them in there. Those are much safer to load test with it open. But a lot of times also when you're load testing a ride for the first time, you're breaking in that vehicle. And sometimes things are missed in the vehicle. Like especially if you're under pressure to get something back together and you're putting it out for the first time, things can get missed. And typically what it is someone's working on something and they leave something in the train. Now, this is a really bad thing that comes to any roller coaster. I don't care what it is. If you leave something in the train, that means you're going to send whatever it is out there on the track. One thing is that the QC, to look over the inspection in between cycles to make sure nothing is there, nothing was left behind. B&M trains and stuff like that, they've got a lot of little cubby holes in some area. If you're working on the top, it's really easy to work on the top of like an inverted roller coaster, and there's a big fiberglass pan up there that covers everything above your head. Well, it's really easy at that point to actually like, oh, I'm using my wrench and I'm doing that, and then it's like, oh, set my wrench down while I'm working on something. And then I get distracted, go to do something, come back, and maybe I'm just finishing up like bending some cotter pins or some locking tabs over, and then I'm like, okay, and I take my ladder away. Well, that wrench is still up there in that fiberglass pan. It's going to come out when you send the train around. And especially if it's tucked up next to something, you might get back up there and just do a quick, up and over and look around and go, yep, everything's out of there, when in reality it was right behind the fiberglass you were holding on to. Rides, when you're load testing them for the first time for that particular train, whatever it might be, you have more of a chance that something comes off the train. Not so much wheels or anything else, but you had a chance to leave a tool in there somewhere and the tool comes off. Now, when it goes to the sandbags, there's a chance for the sandbags to come off of there. This is a reason why, again, we don't load test with the park open for sandbags things, because they can come off. I've had plenty of sandbags come off of stuff because as much as we check them between cycles and make sure everything's down, they start moving. G-force starts pushing them around. And even though they might look secure and feel secure in the station, then once it gets out there on the track, it starts moving. And then that's bad news. Let's see, on the SLC, I've lost 3 or 4 sandbags. They came out in one of the loops, multiple loops throughout the ride. And they make a really big bang when they hit the ground and they kind of splatter and all the sand goes all over the place. One of the most interesting ones I had was on our floorless roller coaster. We lost a sandbag out of the back of the train, which is, if you're going to lose a sandbag somewhere, lose it out of the back because that means the train won't run over it, won't suck it into the wheels or anything else, which is good. But we lost it out of the back of the train. So what happened is actually it came down, and as it was coming down this element, the sandbag fell out and actually hit the cross ties on a B&M track. It hit the cross tie and basically splattered apart. So we saw it, we noticed it. It's like, okay, so we didn't send the train again. We had the crew start taking apart everything, and we went out to survey if there was anything, if there was any damage. Not looking for, like, the sandbag didn't damage a track, but there are sensors out around that area. So I was like, okay, did we hit a sensor? What's going on? We wanted to make sure the canvas material that was holding the sandbag together wasn't stuck on the track still. So we went out there and we made sure, okay, that material was gone. But what it did do, because the sand was a little damp that we used, it actually smashed that sand right into that rail tie. And it was a good couple of inches thick. I mean, it was really thick on there. We just go up there and we just gonna wipe it off. It's like, that didn't work. It was actually slammed in there so hard at, I don't know what it was going there, probably 45 miles an hour, that we actually had to come back with a shovel to take the stuff off the rail tie. It was really stuck on there. And then we were load testing our Skyrocket too, and we had the problem of, it was late at night and we were load testing the thing. We had the sandbags all loaded up, and the lead and myself were standing outside watching it because it was the station was covered. It was indoors. So we were standing outside watching it, and in the dark, as it goes through its slow barrel roll at the very top, we see these 2 things come out and they start falling down. And we are like, oh, did we lose some rags? Like, did someone leave some rags? Mechanics always leave rags on stuff. It's like, oh, did we lose some rags? And then right when they get down to the building, they would boom, boom. We're like, oh, crap. Oh, those are sandbags. Oh, no. So actually it punched 2 very large holes into the building. Luckily, no one down there was anywhere close to it. No one got hurt. But again, these are reasons why we don't like load testing with the park open. And it's inevitable that, eventually you're going to valley the train or do something like that. It's easier to do all your extra work at nighttime. Now, the primary reason why we load test in the evening time or at nighttime is because it's very simple. That is simply when the crew is freed up to actually do the load testing. Now, when you're loading water dummies into stuff and you're filling water dummies up, it's typically we're bringing a train online after its refurbishment. So there's a lot of stuff happening, lots of little last minute checks, lots of little tweaks, lots of this, lots of that. You have lots of mechanics working in the same area. People are bringing water dummies or sandbags. You can also get shot bags as well, they look like a smaller sandbag, but they're filled up with metal shot like you would find in hunting ammunition, like a bird shot and things like that. Little tiny metal BBs, little metal pellets loaded up in there. It works out to be very similar to sand, but it takes up a little bit less space inside there. But the only downside to that stuff long-term wise is that it rusts, and then those bags become rusty, and then you start getting that all over the roller coaster. Nobody likes that. That's one of the reasons we always preferred sand, and we didn't have water dummies. That was the other reason. But we have crew in the evening time that's just dedicated to doing that one process. We don't have to take people off of doing ride calls. We don't have to take people away from doing inspections to rides. We have almost an entire crew of people that can just sit there, finish stuff, bring weight, load it on, and secure it and get it ready. Now, once the weight's loaded on and we've looked at it and said, okay, We've done all of our stuff. We give it a little prayer. That it goes out and comes back. Because that's the worst case scenario when you're load testing, is that it goes out and does not come back. Those are really bad times if you lose a vehicle during load testing. Right now this week, Hyperia's valied once this week anyways, but the ride keeps valeting out there. So it's like one of the things that happens with valied vehicles is that either if the ride does it a lot, like right now Hyperia is doing it a lot, that crew's getting a lot of experience recovering that train, and they're getting it down. Each time they valley a train, it gets quicker and quicker and quicker. Not something you want to be good at, but they'll figure that out. Rides that valley a lot, they typically take about 3 to 5 years to hammer out all the little things before they finally start running smooth again. Okay, so when you start the load testing process from there, what does that look like? Well, the load testing process is typically done off of time. So once the train goes over the lift hill, we typically start a timer. Now, newer rides, the program's already done it for you. A lot of rides do this now. Somewhere on the screen, you can get to a screen and it says, hey, what's my run time? And it will actually have a timer right on the screen that tells you what the run time or the lap time was of that vehicle that's out there. So when we're breaking in a new vehicle, and this is typically just for break-in, what you do is you give it that prayer and you send it over that it comes back. And then when it comes back, assuming it didn't do anything crazy while it was out there, there was no breathtaking moments where you thought for sure it wasn't going to make it. Assuming it did nothing like that, you get the lap time off of it. Now for this, we'll use something really easy and we'll say it was a 2-minute lap time. This is typically measured from the time it leaves the lift hill to the time it shows up in your primary safety brakes or service brakes. So free time out on the track, we're going to say it's 2 minutes for our particular ride. So that first time we sent it over, 2 minutes. It's like, okay, what do we do from there? How many cycles do we need to put on this? The definition of how many cycles isn't really there. I know when parks have accidents or things and the park puts out an official statement and says we need to do this because, when they're telling the general public, they're like, we're going to put 500 cycles on it. They might put 500 cycles or something on it. That's a lot of effing cycles. But for new vehicles, it's typically not that much, not by a long shot. But this is one of the things that parks don't announce. They don't say. So I can speak for what I was doing at the time. I can't even speak for the old park I used to work at right now because I don't know what they're doing anymore because I no longer have control over that. But when we were there, we'd say, okay, we sent the train over. It took 2 minutes. And then what would we do? We'd re-inspect it. We'd make sure all the sandbags were tight. Everything was good. And then we would go send it again. And it would go around the track again. Now, the next time that vehicle came back in and we got that lap time back, it's going to be a little bit faster that time because some of those tight components, now they're starting to wear, they're starting to break in, they're starting to move, and they're starting to free up. So it's like, okay, you start watching that lap time, it'll start coming down every cycle. So the first time, 2 minutes. Next time it's a minute 59. Next it's a minute 57. Next one it's a minute 50. Then it's a minute 45. It keeps getting faster and faster and faster each time it's on its track. You stop it multiple times and you start rechecking parts of the train. This is typically when you look at hitches. Typically hitches are the thing that you want to look at because they might have a burr or something inside of it to where they tightened up and they looked correct when it was all sitting static. It was all by the book, but after it's moved a couple of times and done that motion, after it's been through all of its elements, it might be loose. Not like the whole assembly came loose like it was coming apart, but just that tight tolerance that was supposed to be in that hitch is now wider. And now the thing's got some elastic play in there. You don't want that inside of hitches. So it's crucial to stop it at multiple points throughout the load testing and give the train an inspection. Make sure everything still looks okay as you're continuing the cycle. If something's going to mess up, it's going to mess up during your load test because that's when things typically come out. So you're going to stop, you're going to do your frequent inspections, and you're going to keep running that train. And what you're going to see is you're going to see the time come down. And as it gets down to a certain time, it's going to start to level out. So we're going to say for this, we'll make it up and we'll say that our time's gone from 2 minutes And now we're down to 1 minute 40 seconds. So we've now taken 20 seconds off of our time from the time that we started running the train to the time that's right now. Okay, so minute 20 seconds or minute 40 seconds. And each time it's consistently running 1 minute 40, 1 minute 40, 1 minute 40. I'm going to give that train about 5 cycles and let it hit 1 minute 40 every single time. And then once we hit 1 minute 40, I am going to take weight off of the vehicle. Now, the way we've done this is the way we figured this out. It works the best is we take weight from the front of the vehicle first. We always take it from the front and work our way backwards towards the back. We've just noticed that worked good for our particular rides, our situations, our humidity, temperatures, variance, everything else. Every park does something different. Some start from the middle and they go outwards. Some start from the back. Some don't even do this process, so take it with a grain of salt. But basically what you do is you're going to start from the front and we're going to take 4 seats off. And we're going to say, okay, all 4 water dummies out of the front row, assuming we're using, let's say, a B&M invert or something like that. All 4 water dummies off the front row. We take those 4 water dummies off and then we run the train around. Now, it was doing minute 40s. Now, after a little bit, it jumps up to 1 minute 42. Now, by unloading 1 row, we've now put 2 seconds back on the train. Now, this is a point where the primary mechanic for the ride, this would be the mechanic that normally spends the most time with whatever ride you're dealing with, is going to know, like, okay, normally when he pulls a train out first thing in the morning and sends it around and it gets nice and warmed up, he says, oh yeah, normally we do about 1 minute 50 unloaded in the morning time, but warmed up, 1 minute 50. It's like, okay, so loaded, now we're running 1 minute 42 seconds. And then you might unload the next row after a couple cycles, and then it might go up again to 1 minute 44. And then you're running some more cycles. Now, one thing you watch for during this time you have to watch very carefully for it, is you have to watch for a problem, because during the unloading process while you're taking weight out of the vehicle, taking it down, if there is a problem, you would see it normally with your times. Your time will slow down. You're like, oh, the vehicle is going slower. Something's going on. We need to take it off and inspect it. If you're taking weight out of the vehicle as you're doing your testing, you're expecting the times to start slowing down. So you have to be very careful about it. So if you take a row off and it adds 2 seconds to your lap time, after another 5 seconds, if your time is still continuing to go up, and now you're 3 seconds, now you're 4 seconds, that's when it's like, okay, wait a minute, we have another problem. We got to take the vehicle off and find out what's going on, because something is happening. What happens when we first get into a train and start load testing it? That's when you could have an erroneous, like a wheel bearing, just lock up on you for some reason. And it might not completely stop the wheel, but it's like turning the brake on and running your car with the brake on. It just slows the vehicle way down. And it might lead to a valid train eventually. So you have to watch for those times coming up. But you should see the time should be stepped. Every time you take weight off the vehicle, the time should jump up by a step, whether it be a second, 2 seconds, whatever it might be. So it's like, okay, and you just keep running that. I typically undo 1 row, run 5 cycles. The next row, 5 cycles. Next row, 5 cycles. Next row, 5 cycles. And I do that until the vehicle is completely unloaded and we're running empty cycles with nothing on it, and it's just that vehicle running by itself. Now, one of the things you could finally tell once the vehicle is unloaded is how fast it goes. If your old vehicle broken in is running 1 minute 50, and now this new vehicle is running 1 minute 48, well, the new vehicle is much tighter. All the tolerances are better, so it's going to run faster. No question about it, because the older vehicle has more slop in it. It's been running for longer. It's tired. It's ready to come off the tracks, right? So you have to watch those times and say, okay, so where you run into concern is when you get fully unloaded and that new vehicle is running way slower than the old one. Like the new vehicle is almost back up to 2 minutes. Then it's like, okay, we need to go back and look at the train again. Something's wrong. Got to figure this out. So, but during this time, when you have no weight in it, it's also the first time you can hear the train. Because before, with all the water dummies loaded in, sandbags, whatever it might be, you might have plastic wrap around the thing. It might be making all sorts of noise out there on the track from all these things on it. And now that's the first time you can hear the vehicle by itself running quiet. And then that's when you might hear it go around out there and be like, there's a fiberglass panel that's loose on that thing. Because you could hear it go, it looks, sounds fine, and it goes around that turn, and you start hearing it's like, as it goes by, it's like, dang it, there's a fiberglass panel that's loose out there. So you come back and you start looking at your fiberglass and start shaking things. Where are you? Find out, oh, it was a bolt that wasn't running all the way or something. Take it out, Loctite it, run it back in there. This is when you find all those things for the first time. Now, when we're done with load testing, we put the vehicle away, we put everything away. Is that vehicle ready to go for people on it? Absolutely not. That thing's been run hard, put away wet, right? That's always the phrase you use because you just got all the water all over the thing. So it's run hard, put away wet. So once that thing's back in its work bay, that's when you have to go back through everything and you have to re-inspect everything. It needs a full inspection. Most of the time, if your mechanics are very proactive and they're really out there trying to get in everything working perfect, while they're load testing, they will be doing other things. For instance, most rides, mechanics will grease the hitches continually while the ride is running because all those grease cavities don't have a lot of grease in them to start with, so the mechanics want to make sure they get the break-in grease in there, but they also get the proper grease in flowing through those systems. Do rides use, I just said break-in grease, do rides use a special grease to break in? No. So what happens is that you can have a big pin go into a bore, and the manufacturer says to coat that pin with grease when you put it in the bore. So you reach in, you coat the bore with grease, you coat the pin with grease, and you put the whole assembly together. Well, the grease fitting goes into that opening, and that opening might have an entire tube's worth of grease in there that's not there anymore. It's gone because that was the old grease, you cleaned it out. So you literally have to pump new grease into there, an entire tube's worth, before just the cavity is filled, and then new stuff starts coming out. Any mechanic knows that you pump grease into it until you see new stuff come out. Sometimes that's not what you want to do. Vertical like hitches overhead are one of those things. Pump grease into it, send it around. Just a little bit, send it around. And then after a while, you'll start seeing old grease start to come out from around the fitting, and then you wipe it up and you say, okay, we're good after that. You have mechanics sometimes on hitches overhead. I've talked about this before in other videos. Pump grease into it until new grease was coming out, and then the next bunch of cycles they ran, they had a lot of grease coming out. So much for it was coming down, dropping onto the seat of the ride, and it's just like, way too much grease. You over-greased that thing. That's harder to tell on new rides because when you put grease into an assembly, you're not sure if it's going into an open cavity, or when they put it together, did they try to like pre-pack the cavity, which some places do. I take a tube of grease, squeeze it inside that cavity, and then use like a scraper tool and fill the cavity up before you put the pin in. That way, all the grease is in there, cavities are packed. Manufacturers sometimes specify to pack the cavity with grease, but lots of greasing happens after you're done load testing a train. The water that comes off the train sometimes gets down there and it washes off some of the grease. Any rollbacks, chain dogs, stuff like that start to get really loud and noisy because they've washed the grease off of them. That brand new grease that was just in there, now it's just got a bunch of water that went through it. So you need to reapply more grease. When you're doing sandbags, sometimes you have bags break while they're in the train and then you get sand all over everything. So you have to really clean that off and really grease the crap out of that too, because you don't want sand in that assembly. That's not going to be a good thing at all. So earlier I mentioned suspension. So I think this will be the last talking point I go over. So the suspension of the train. Vehicles, trains in general, they do have suspensions. So they're typically made up of very hard rubber components that have axles and pins and stuff like that floating around on the inside there. When you put that vehicle on, they have their ride heights and stuff set by all those rubber bushings. Sometimes something gets in there, maybe the bushing gets crooked on installation and it binds that assembly up. And then you might set the ride height or something like that in there. Some manufacturers have settings for this stuff. You can actually go in and adjust heights and things like that with these bushings, with shims and stuff like that. A lot don't. So sometimes you might see something where you have to set something to a critical measurement, has to be a certain dimension inside there, and then you go run the vehicle around a bunch of times and come back and that dimension's way off. It's a lot shorter or it's a lot taller now. It's like something happened in the vehicle suspension. I know the older style, but I'm pretty sure the new style is the same. The older style RMC trains that I'm used to working with, those things had a lot of suspension points on the inside, guide wheel, up, stop wheel, that sort of stuff. They had lots of bushings and collars and springs and stuff like that in there for the suspension of the vehicle to keep it centered left to right. So there was some shimming and things like that you had to do to make sure that suspension was nice and tight, even, and it had the correct pressure against the track rails. Well, that all might change during load testing. Something finally moves and now it's where it was snug, now it's loose. That's a big problem. Impulse coasters, LSM, LIM, whatever you're talking about there, all those wheel assemblies, all the guide wheel adjustments, everything shifts once it's load tested. Once it's had that weight put on it that first time and sent around a bunch of times, all that stuff that you set perfectly in the train the first time before you sent that, now everything has moved. And you have to, for LIMs are the worst. LSMs, you need to readjust them to where everything's back to where it should be. LIMs, since their tolerance is so tight, 2 millimeters tolerance is all it is. It's very tight. So LIMs, once you run those things, everything shifts just slightly, and then next thing you know, it could be during load testing, you start smacking stators as the ride goes out there. Now, LIM's a dying breed, and there's not really many of them left out there. I understand that. Good reason. I mean, man, I prefer LSM over LIM any day, just because of the tolerances. Much different. So, way easier to adjust in LSM. But I mean, if you're talking about a train that goes forward and backwards over any driven source, I don't care what it is, you have to make sure the wheel carriers are pointing straight ahead and all that. And again, after load testing, all that stuff shifts. Sometimes during load testing, it shifts, which is a fun one because it's like it might run fine, and then you take a coach worth of water dummies off, and now it starts hitting stators. And it's like, wasn't doing that before. You could put the water dummies back on there, and it will stop hitting the stators. Take them back off, it starts hitting stators again. It's like, somewhere in the guide wheel assemblies up there, something's off. You got to go up there and figure it out. Sometimes that stops the load testing process cold. You don't want to damage stators. That's bad news. Bad news for the train. It's bad news for the track. So you want to keep those things running straight. Okay, not a bad length for the video today, I feel like, but this is some of the basics of load testing rides, some of the reasons why we do it, some of the things, what happens to the rides during load testing, before and after, and some of the background that I have in the stories. If you liked it, make sure you like, subscribe, do all that stuff downstairs. If you want to email me, you can email me at ryantherideMechanic@yahoo.com. And stay off the air gates. Bye.